Welcome back to this new edition of Science Modernizers. Today we are going to proceed with the state registered nurse for midwife and health technicals concours 2022. So we are going to be solving the physics session. So the instruction says choose the correct answers. If you make a mistake, put a cross on the incorrect and circle the correct letter. Question number 1. Two forces F1 and F2 have the same intensity and are parallel to the point O. They make between them an angle of 120 degrees. Determine the sum of these two forces. So we will take F1 equal to F2 equal to 6 Newton. So that information is very vital. So I have F1 is equal to F2, which is equal to 6 Newton. So those are the magnitudes of our forces. So let us analyze the problem. So I'm going to draw two forces in such a way that the angle between these two forces is 120 degrees, and so I can draw a referential horizontal line which passes as such. We can draw a referential horizontal line which passes as such. And so since these two forces have both intensities, this is 6 Newton and this is 6 Newton, so their actions are definitely going to be the same. So the measure of the angle with respect to the x-axis will be 30 degrees and this one will be 30 degrees. So they all sum up to 180 degrees. So let's get now the sum of these forces. So we are going to resolve these forces on that plane. So we are going to have a system like this. I apologize for my diagram not being straight. So the measure of the angle between them is 120 degrees. So we saw that the measure of this angle is 30 degrees and the measure of this other angle with respect to the x-axis is 30 degrees. Then here we have 6 Newton and on this other way we have 6 Newton. So let's resolve this system. So resolving this system, we are going to have components. So I have the first component to be the horizontal component of this 6 Newton force here. So this horizontal component I'm going to bisect with respect to this vertical line. So I have that component and this other component. So we see that this configuration, the configuration as such, forms a right angle triangle. So with a right angle here, likewise this other sector with a right angle at this point. So we see that this forms a right angle configuration in which I can have the components of these forces. So here I have the vertical component of this force will point in the vertical direction. So it's going to be as such. So it means the component here, since it is opposite to the angle, is going to be 6 times sine 30. Likewise, this other person, the other force, 6 Newton, the force is going to act vertically upwards. So this is the direction of that force of the vertical component, which is also going to be 6 times sine 30. So for the horizontal component, we will have 6 times the cosine of 30. Likewise, here we have 6 times the cosine of 30 acting in opposite direction. So we are going to get the resultant. So the essence is for us to look for the sum of the forces. So if we take the sum, the resultant force, that's the sum of the forces along the y. So what we are going to get is the resultant force will simply be the sum of the forces along the y, or the resultant force along the y will simply be, since these two forces 6 sine 30 and 6 tan 30 are in the same direction, so it means that the sum of the two will simply be 2 times 6 sine 30, but sine 30 is equal to half, so this will simply give us 6 Newton. Now along the x, so the sum of forces along the x will be equal to, so I'm going to have, since they act in opposite direction, it will be 6 cos 30 minus 6 cos 30, which is going to be 0 Newton. So we see that the sum of the forces along the y-axis gives us 6 Newton. So it definitely means that the resultant of those forces will be 6 Newton. And so the correct option in this question will be option A, 6 Newton. Question number 2. An ideal gas at constant temperatures during this process expands at constant temperature. During this process, A, it absorbs it, B, it absorbs it if only if it is an ideal gas. It does not absorb it, therefore the temperature does not change during the process. D, no answer is correct. So the correct option here is option A, it absorbs it. So why does it absorb it? Since the temperature is constant, it means that the variation of the internal energy is zero. And in other words, the heat absorbed by the gas is equal to the work done by any ideal gas. The heat absorbed by the gas is equal to the work done by the ideal gas on its surrounding. So the correct option is that it absorbs heat. So question number 2, correct option A. Okay, so question number 3 reads, a nail provides 220 volts of resistance RMS value of 44 ohms. The power dissipated in the machine is, so we simply use the expression, the voltage is given and the resistance is given. So the question unfortunately does not present the units very well. So, but the power P is given by V squared divided by the resistance. So if the power is 220 volts, we have 220, all of that squared divided by the resistance, which is 44. So if you solve 220 squared divided by 44, you are definitely going to get 1100 watts. So the correct option is A. Then question number 4. A block of metals weighs in water 1/3 the weight it weighs in air. The density of the metal compared to the density of water is A, twice as high, B, 1.5 higher, C, half, D, equal. So question number 4, what we are supposed to do there is, the first thing is, if you have immersed, we have, let's see, I have my solid or a mass which weighs in air, and the weight of this mass is W. Now I bring it in a container which has a certain volume of which contains water. And then we now represent the mass. So it means I have this. So we are definitely going to observe an apparent change in the weight. So the apparent change in the weight is what we call the buoyant force, and the buoyant force is given by the weight in air minus the weight in water. So it means we can definitely come along and calculate the buoyant force. So the buoyant force B will be equal to the weight in air was given by W minus the weight in water is W divided by 3. So taking the difference, we have 3W minus W divided by 3, which gives 2/3 W. So that's the weight. So but the buoyant force is since it is the difference between the two, so the buoyant force will simply be given by the density of water. So the buoyant force will be given by the density of water times the volume times G, which is equal to 1/3 times the weight of the block or the weight of the solid will be mg. And since the weight is given by mg but the mass is given by the density times the volume, so I have rho vg. So this is the density of my solid. Sorry, here is 2/3, not 1/3. Now this volume which you see, this is the volume of the water displaced, and the volume of the water displaced is equivalent to the volume of the solid. So this quantity Vg and Vg will cancel. So we are looking for the density of the solid with respect to that of water. So it means we have rho S divided by rho W to simply give us the ratio 3 divided by 2, which is 1.5 times higher. So the correct option is option B. Option B. Now, question number 5 reads, we have a sample. A sample of radioactive metal contains 1030 atoms. If the half-life is 6 hours, then the number of atoms in 30 hours will be. So we can use the number of atoms at a given time t from the radioactivity formula. We have that the number of atoms at a certain time t is equal to n naught times e raised to the negative lambda t, where lambda is equal to the natural logarithm of 2 divided by the half-life. So let's then calculate the number of atoms that will be left at time t. So we are looking for nt. Nt is what we are looking for. So nt will be equal to n naught. Initially we had 1030 atoms times e. That should be 10 to the 30, not 1030. So I think it is a mistake from the board. Okay, so that will be 10 to the 30. We'll use 10 to the power 30 because the answers, all the answers in terms of exponents. So it will be 10 raised to the power 30 times the exponential of negative lambda t. Negative lambda, that will be negative ln 2 divided by t half, but the half-life is 6 hours. No need of converting since all the times are given in hours. So all of this will be times t. So we are calculating for 30 hours. So the numerical application gives 6 goes here, 6 goes here 1 time, and it goes here 5 times. So I have, this will be 10 raised to the power 30 times e to the negative 5 times the natural logarithm of 2. But from the laws of logarithm, this negative 5 can move upwards. So it means I'll have 10 raised to the power 30 times e raised to the natural logarithm of 2 to the negative 5. Now e to the ln a is a, so it means the number of atoms at the time t will be 10 raised to the power 30 times 2 to the negative 5. And 2 to the negative 5 is 1 divided by 2 raised to the power 5 times 10 raised to the power 30. So if you simplify that expression, you have 1 divided by 2 raised to the power 5, that's 0.0315. Then you multiply by 10 raised to the power 30, and the correct option and the correct answer will be 3.125 times 10 raised to the power 28 atoms. So if you go above, you check 3.125 times 10 to the power 28. So the correct option there is approximated to be option D. So option D is the answer. So it means that this 10 to the 1030 is actually 10 raised to the power 30 atoms. Okay, so take note of that correction. Okay, question number 6. Question number 6 says an intrinsic power and commercial magnification of a microscope are related by the relationship API is equal to, the intrinsic power is equal to 4 times the commercial magnification, PI is equal to the magnification, the commercial magnification divided by 4, PI is equal to the commercial magnification divided by 2, and D, no answer is right. So the correct option there is D, no answer is right. So the expression of the intrinsic power PI, the expression of the intrinsic power PI is simply given by the commercial magnification divided by the angular magnification. We call it delta. So we clearly see that none of these options here corresponds to that. So the answer, correct option is no answer is right. Question number 7. If the Earth exerts a force of 9.8 Newton on the mass of 1 kilogram on its surface, it is moved to a point at the height above the Earth and twice the radius of the Earth. The force on M is, so this is the Earth, So we have the earth, and at the surface, the weight at the surface is given by 9.8 Newton. So I'll call that W naught. And we know that the expression of the acceleration due to gravity on the Earth's surface is given by gm all over r squared. Now we have a body of mass. This distance is r. Now the mass is at a given distance. We are at another distance of r away from the surface. So this is where our point mass is. So the expression of g, let's call it g prime, at that height will simply be gm divided by the new height is 2r. So I'm going to have 2r all of that squared. So this will give me gm divided by 4r squared. But gm all over r squared initially is our g. So let me call it g naught, and I'll call that w naught. So it means g prime will simply be equal to g naught divided by 4. So if it is g naught divided by 4, you know that the weight w is given by mg. So the weight at that height, let's call it w prime, will be equal to the mass, which remains constant, m, times g, and g prime there is equivalent to g naught divided by 4. So this will be equal to mg naught all over 4. But the value of mg naught is the initial, that's the weight on the surface of the earth. So this will simply give us, and the weight on the surface of the earth was given to be 9.8 Newton. So this is 9.8 divided by 4. So 9.8 divided by 4 will give you 2.45. So this will give you 2.45 Newton. So check the answer. So it means it's structural. Maybe the options were not given, so the answer is 2.45 Newton. So that is the answer. Question number 9. A simple pendulum has a period. A simple pendulum has a period. A simple pendulum has a period of t on Earth. If this pendulum were used on a planet X, where the acceleration due to gravity is 4 times the acceleration due to gravity on the Earth, its period will be, so the period of oscillation of a simple pendulum t is equal to 2 pi times the square root of L divided by the gravitational field strength, where L is the length, L divided by g. L is the length and g is the gravitational field strength. So if the gravitational field strength, let's call this period t naught, I call this t naught, so the length of the pendulum remains unchanged. So if the gravitational field strength on Earth is g naught, and we go to a certain planet X where the gravitational field strength g prime is equal to, is 4 times the value of the acceleration due to gravity on Earth, so it is 4 times g naught. So I'm going to replace in order for us to get a period t prime. So it means our period t prime will be equal to 2 pi times the square root of L divided by g prime. But g prime is simply given by 4g naught. So I have 2 pi times the square root of L divided by 4g naught. So we get t prime will be equal to, so you see that 1/4 can be factored out, and 1/4 is the square root of 1/4 is a half. So I can write that as a half into 2 pi times the square root of L divided by times the square root of L divided by g naught. But 2 pi times the square root of L divided by g naught is t naught. So it means t prime will be equal to a half t naught, or t naught divided by 2. So it means the correct option is A. So question number 10 says the density of water is 1 gram per cm cube. What is the mass of 4 meters cube of water? So the density of water is equal to 1 gram per cm cube. So the density of water, let's convert it to SI units. So the density of water will be 1 gram. 1 gram means 1 times 10 to the negative 3 kilograms per cm cube divided by 1 cm cube. So 1 cm cube from centimeters to meters, remember we divide by 100, so it's 10 to the negative 2, all of that cube. So it means the density of water will be equal to 10 to the negative 3 in meters cube. 10 to the negative 3 divided by 10 to the negative 6 meters cube, and this gives us a value of the density of water to be equal to 10 raised to the power 3 kilogram per meter cube, which is a standard. Now the question says what is the mass of 4 meters cube of water? So density is equal to mass 1 over volume. So this means the mass will simply be density times volume, which is 1000 or 10 to the power 3 times 4. So the correct option is 4 times 10 to the power 3 kilogram. So amongst the option there is no correct answer. So option B was supposed to either be 4 times 10 to the power 3 kilogram, or option D was supposed to be that answer. So the answer was between option B and option D. So with that there is no answer. So the answer is 4000 kilogram. Okay, question number 11. An electric motor with an internal resistance of 2 ohms, 2 ohms of an internal resistance of 2 ohms delivers a current of 5 amperes to a load consisting of a resistance R is equal to 30 ohms. His EMF is, so let's get the question well. An electric motor with an internal resistance of 2 ohms. So we have internal resistance R is equal to 2 ohms. R is equal to 2 ohms, and the current I is equal to 5 amperes to the load consisting of a resistance R which is equal to 30 ohms. So we are asked to calculate the EMF. So the EMF E, when current of the electric motor as it delivers current, will be equal to V plus IR, where a small r is the internal resistance, and V can be gotten from Ohm's law, which is capital IR plus IR. So this expression can be simplified as I into R plus small r. So we get that the EMF E will be equal to the value of the current was given to be 5 amperes. So we get 5 amperes, 5 into 30 plus 2. So this gives me 32 times 5. So in accordance to what is in the question and the values that are given in the question, we observe no answer, since 32 times 5 is equal to 160. So this will give me 160 volts, which is no answer. Now if we modify the value of the internal resistance, because it is written as 2 kilo, so it definitely means there is an error at the level of this internal resistance when they were setting the question. So it means if we correct this value to a certain 2.5 as internal resistance, then we are going to have an option. So let us verify that if the internal resistance small r, if R is equal to 2.5 ohms, then we will get that E will be equal to 5 into 30 plus 2.5. So this will be 32.5 times 5, and 32.5 times 5 gives us 162.5 volts. So we have 162.5 volts. So we observe that with 2.5, with R corrected to 2.5, we get a value which is option D. The next question number 12 says f. The formula f is equal to 9 times 10 raised to the power 8 q prime divided by r squared. Q and Q prime are in coulombs, R in meter and F in Newton, corresponds to the law of Newton, Coulomb, Faraday. No answer is right. So the correct option is no answer is right. The Coulomb's law of electrostatic, F is equal to K times Q prime divided by the separation R squared, where K is a constant of proportionality given by 1 divided by 4 pi epsilon 0. 1 divided by 4 pi epsilon 0. And epsilon 0 is the permittivity in free space, which has a value of 8.85 times 10 to the negative 12 femto per meter. Now this, if we substitute this value here, we have an approximated value of K to be 9 times 10 raised to the power 9 in SI units. So this value of 9 times 10 to the power 8 is not the value of K. So definitely the correct option here is no answer is correct. No answer is correct. So the correct option is option D. Okay, question number 13 says an object of mass 1 kilogram is in balance suspended from a vertical wire. The force exerted by the wire is, so we have, it is balanced, it is here as such. So we have it here, and here we have, it is balanced. So the only force it experiences is mg. So that's our fixed support. So since the mass is 1 kilogram, so it's going to be the force exerted on the wire will be the tension force. So here we have T. So you see that T will be equal to mg at balance, which is 1 times 9.8, which is going to give us 9.8 Newton. So the correct option is option C. The correct option. Option C is the correct option. Now the next question. The next question reads: the charge, a particle of charge Q, moving with speed v in a uniform magnetic field B, undergoes a magnetic force such that F is equal to QV cross B, is called the force of A Planck, B A Newton, B Planck, C Lorentz, D. No answer is right. So the correct option is Lorentz force. So that's Lorentz force. And in general, Lorentz force, when a charge is moving with a given speed under the action of an electric and a magnetic field, F is equal to Q into E plus Q into E plus VB. V cos B. So that is the expression, the general expression of the Lorentz force when a charge is moving inside a field, that is, and it experiences an action of both the electric and the magnetic field. So the general expression of Lorentz force is equal to Q into E plus V cross B. So F is equal to QVB is a simplification of the Lorentz force. So the correct answer is option C. So question number 15. Question number 15 says a body weighs 980 Newton, then its mass is, so the weight of a body W is given by mg. So the mass will be equal to the weight divided by the acceleration due to gravity. So the mass will be equal to the weight, which is 980 Newton divided by 9.8, and this will give us 100 kilogram. So the correct option is D. Correct option is D. So the next question says, if we consider a particle, we consider a point M moving according to the hourly law. Hourly law, there's a F of T. according to the hourly law S of t or f of t, because it is a displacement equation. So I will call it S of t. S of t is equal to 2t cubed minus 6t plus 4. The expression for the moving acceleration is, so the acceleration is the second derivative of the displacement with respect to time. So in order for us to go with it gradually, the first thing we are going to do is to obtain the speed of the particle at the given time t, which is the derivative of the displacement, with respect to time. So this is going to give us the derivative of 2t cubed is 6t squared, and the derivative of 6t is 6. So the acceleration a of t is given by the derivative of the velocity v of t with respect to time, and this will be equal to, so when we differentiate this, we have 12t, and the derivative of 6 is 0, so it means the acceleration will be given by 12t. So the correct option is C. Next, so the next question reads, a boy on a bicycle, sorry about this. A boy on a bicycle is traveling at 20 meters per second. What is the angular velocity of the tire valve if the tire has a radius of 0.3 meters? So a boy is traveling with a speed of 20 meters per second, so the linear speed is related to the angular velocity by v is equal to omega r. So it means omega will simply be equal to the speed divided by r. So we get omega to be equal to, the speed is 20 meters per second, that will be 20 divided by 0.34. So it means omega will be equal to 58.82. Omega will be equal to 58.82 rats per second. So the correct answer will be A, though it is too far from the reality. Next, which of the following statement is correct when changing state? A, the internal energy of the system increases. B, the latent heat is absorbed. C, the work is done and the ties are broken. D, the work is done and or the links are broken or belt. So when there is a change of state occurs at constant temperature, and at constant temperature internal energy is constant, so option A, it does not increase. So at constant temperature, latent heat is absorbed, because latent heat is actually, it is either absorbed or released, but the process takes place at constant temperature, so it takes place when temperatures does not change. So the correct option there is B, latent heat is absorbed. Okay, question 19 reads that a rod of negligible mass is mobile around an axis delta perpendicular at O to the plane of the figure. O equal to 20 centimeters and AB equal to 50 centimeters. We assume that we have masses marked with brackets. The total value M is equal to 300 grams. What mass should be suspended at E to maintain the rod in the horizontal position? Now we are going to realize that the position of the masses in which their sum is 300 grams was not indicated on the diagram. So we are going to place all the masses at point B. We are going to place them at point B since it was not indicated on the question. So we have something of this nature. we have, this is our rod AB. So this A, this B. So we are going to place the mass here. So let's say there are two masses which are overlaid as such, and the weight of these masses will be mg, and the mass is 300 grams. So that's 300 grams, which is equivalent to 0.3 kilogram. So the weight will be equal to 0.3 times acceleration due to gravity. That's 0.3 g. Now we have a pivot which is placed at a given point O. It is placed somewhere here at a given point O, and we have a reaction force on that pivot. We call it R, and so the distance from A to O is 20 centimeters, which is equivalent, or which is equal to 0.2 meters, and the distance from B, from A to B, is 0.5 centimeters. So the length of all this is 0.5 meters. So that's 50 centimeters, and so this remaining portion of the rod will be 0.3 meters. And so the question says, what mass should be suspended on A to maintain the rod in a horizontal position? So here we suspend a given mass, we call it M, in which the mass will have a force mg. So we have to calculate the value of M using the principle of moments. So the principle, from the principle of moments, the sum of anti-clockwise moments should be equal to the sum of the clockwise moment, should be equal to the sum of clockwise moments. And so I'm going to take my moments about the pivot, that is about the point O. So taking moments about that point, we observe that the force mg is going to behave as such. So that is an anti-clockwise force, and the force, the moment, is given by the force times the perpendicular distance from the line of action of the force. So that will be mg times the perpendicular distance from the line of action of the force is 0.2. That's right up to the point of application of the moment. So it's going to be 0.2, and this will be equal to this other force is 0.3, is going to cause a turning effect in this manner, and that is clockwise. So it's going to be 0.3 g, all of this, times the perpendicular distance from the line of application of the force, that's 0.3 meters. So if we simplify, g's we cancel out, so g we cancel out, g we cancel out, and I'm looking for m. So it means m is going to be 0.3 times 0.3 divided by 0.2. So 0.3 times 0.3 is 3 times 10, 9 times 10 to the negative 2. All of this divided by 2 times 10 to the negative 1. And 9 divided by 2 is 4.5. 10 to the negative 1 goes up, we have times 10 to the negative 1. And so the result will be 0.45 kilogram, which is equal to 450 grams. So if you check amongst the options, there is no answer as such. So the issue is we don't know the exact position of the mass. We don't know the exact position of mass of M. But if M is placed at A, then the correct option here will be no answer is correct. The potential energy, question number 20, the potential energy of a body of mass 10 kilograms, which is 10 meters high, is, so the potential energy PE is simply given by mgh. So the potential energy is equal to mgh. So the potential energy will be equal to the mass, that's 10 kilograms, times 10 meters times 9.8. So that is going to give us 980 joules. So the correct option is A. Okay, so this brings us to the end of the physics lesson, and it also brings us to the end of this video. Please endeavor to like, share and subscribe. Thanks for watching, and see you in subsequent videos.